Hello and welcome to another lesson on functions. In this lesson, we will talk about piecewise functions. So what are piecewise functions? So piecewise functions are simply functions that can be written using two or more expressions, or it can be defined as a function that consists of two or more rules for two or more of its intervals. So since a piecewise function is made up of different parts, so it has different rules for different parts of its domain as well. And a piecewise function can either be continuous or not, depending upon the points at which it is being pieced together. It can have different kinds of discontinuities like whole discontinuity or jump discontinuity. So let's take a look at an example to see that what is going on here. And so in this example we have three different intervals, and if we plot them using table of values, we can easily get it's in the graphical form. But if we want to check that whether the graph of this piecewise function is continuous or does it have any discontinuity, so there is a simple point that we should keep in mind. So the graph of a piecewise function is continuous if the functions that are being pieced together have the same value of y at those points. For example, in this first function of this piecewise function 2x plus 6, we have values that are less than or equal to -2, and for the next function where the function is changing, the function becomes -2x minus 2 at values greater than -2. So if these two functions evaluate them at x is equals to -2 and the values come out to be the same, then we can say that it is the graph of this piecewise function will be continuous at -2. And for the next one, if we evaluate this function and the last function at x is equals to 0 and the graph comes out to be continuous at x is equals to 0, then we can say that the graph will have no discontinuity. Let's check it. And if we plug in -2 here, then we'll get a 2 here, and if we plug in a -2 here, we'll get a 2 here. So we can see that we have the same value of y. So the function that for these two functions, so we have a continuous function here at x equals to -2. Same goes for this 0. So if we evaluate these two functions at 0, we'll get a -2 here, and we will get a -2 here as well. So the function is also continuous at x is equals to -2. So there is no discontinuity in this piecewise function. So if we plot this function, you can clearly see that this function consists of three different intervals. Okay, for this first interval, we see that we have an increasing interval, right? Because the value of y is increasing as we are moving from left to right. Then we have a decreasing interval for the second function, and then again we have an increasing interval for the third interval, 3x minus 2. So let's talk about a typical example of a piecewise function, that is the absolute value function. So if we talk about the piecewise representation of an absolute value function, it consists of two intervals. For the first interval, we have x that is less than 0, and whenever we have x is less than 0, we have negative value of x, and for the other one we have x is greater than or equal to 0, and for that we have positive value of x. Now if we want to see that whether we have a discontinuity in this interval or not, we just have to evaluate x and negative x at the point where these two functions are being pieced together, that is at x is equals to 0. And if at x is equals to 0 these two functions have the same value, then we can say our functions are continuous. Otherwise they have some kind of discontinuity here. So we can check and we easily see that we will get 0 for both. Okay, so when we have to plot this graphically, we just have to take a table of values and take different values and then plot those values and then join them with a straight line. So we can see that for these two intervals we have two increasing and decreasing interval. If we start from the left, first we have a decreasing interval, right, till O, and then we have an increasing interval from 0 to positive infinity. So let's talk about a discontinuity in a piecewise function, and in this example we have two intervals, x square at x is less than 2, and the other function is 3x plus 4, at x is greater than equal to 2. So if we want to check that whether our graph is continuous or not, we just have to evaluate these two functions at x is equals to 2. So at x is equals to 2, x square 4, and for the other function 3x plus 4 at x is equals to 2, we have 3, 2 plus 4, 10. So you see that at x is equals to 2, these two functions that are being pieced together do not have the same value of y. So we can say that there is some kind of a discontinuity, or we can say it has a jump discontinuity at the point where these 2 points are being pieced together. So let's take a look at the table of values first. You can take different values for x square, and you can take different values for 3x plus 4 as well, and then you can plot them easily on a graph as well. And you can clearly see here that at x is equals to 2, for this parabola that we have for x square, we have a parabola that is coming from the left and opening up, and then suddenly, because we have this restriction on it, and then our interval changes, we have a jump here. Okay, and the value directly jumps from 4 to 10, and that is why we have a jump discontinuity here. So that's it from today's lesson, and thank you for joining.